Hey everyone, welcome back to our summer science session. For our third week, we're going to be talking about static electricity and doing some experiments, and we're also going to be talking about simple machines. Let's get right into it. Now, before we can talk about static electricity, we have to talk about something called subatomic particles. Now, we know atoms as the building blocks of everything, but what are the building blocks of atoms? What are atoms made up of? Atoms are made up of three subatomic particles called protons, neutrons, and electrons. Now, each of these three particles have a different charge. So protons have a positive charge. Protons, the P in proton, you can think of it as positive. Neutrons have a neutral charge. They have zero charge, not positive or negative. Electrons have a negative charge. Now, positive and negative charges attract each other. Just like opposites attract in a magnet, the north side of a magnet and the south side of a magnet attract each other. Opposites attract, while the north side of a magnet and the north side of a magnet repel against each other. Just like a positive proton and a positive proton, they will deflect. They won't want to join each other. But a proton and an electron will want to join. So static electricity is the imbalance of electrons. Electrons are the ones that flow from one object to another. The flow of electrons is electricity. So what's happening when you rub your sock on a carpet and you touch somebody and you give them an electrical shock, static electricity, what's happening is there's a transfer of electrons from the carpet to your sock. So now your body is an imbalance of electrons. It wants to get rid of those electrons. So as soon as you touch somebody, those electrons are flowing to that person and giving them a tiny shock. So that's how static electricity works. So right here we have a little experiment using static electricity. What I'm going to do is I'm going to use this towel to create a lot of friction on this plastic coat hanger, giving it a high negative charge. Lots of electrons are going to jump on this coat hanger. You can also use a plastic comb and comb it through your hair because all the electrons in your hair will jump on the plastic comb. Alright. So now this coat hanger is full of negative charges. I'm not going to touch it. And I'm going to start a tiny little stream of water from this faucet. And this water actually has a neutral or slight positive charge. And I'm going to use the negative charge of this, coat hanger to actually bend the water. It'll be attracted to it. Just like that. It's being attracted to the negative charge. Pretty cool. Another cool little spooky experiment you can do with static electricity is making this tiny little tissue paper ghost dance. First thing you want to do is fill up a balloon, rub it against your head, or a carpet. Now the electrons from my hair will transfer to the surface of the balloon, giving it a negative charge. And once it has enough of a negative charge, it can actually lift small objects. Try from a different side. So you make the tiny little ghost dance. Now we're going to be moving on to our next topic and talk a little bit about simple machines. Now what a simple machine is, it's a basic mechanical device that allows you to accomplish a task using less energy, less work, and less force. One of the most common simple machines is a lever. If you've ever seen a seesaw, it's a lever, it's a first-class lever. What happens is you have a body, you have a fulcrum, which is what the body pivots on, and you have a load. So to lift this load using a lever would be way easier than just lifting the load directly up like this. And the reason why is because you're using a downward force to exert an upward force on the load. And that's easier because you have gravity on your side. It's easier to exert a downward force than an upward force. So it's a lot easier to do this with a heavy object than just lifting it up directly. And that's the principle that a lever works on. So our next simple machine is a pulley, and this pulley is very similar to a lever in the sense that it has a load, which is the object that it's trying to lift, as well as the fulcrum, which is the part where the system pivots on. So this pulley operates on the same principle as a lever. It's easier to exert a downward force than an upward force to lift a heavy object. So if I pull this side of the string, if I put my effort downward, I have to use way less energy and way less work than if I were to use that same force to pull that load upward. And that's how I can pull a load upward using downward force. Our next simple machine is called an inclined plane, also known as a ramp. What this simple machine does, it gets an object from a lower level to a higher level using much less force than just directly picking it up against the flow of gravity. It disperses the force over time instead of using a lot of force and a lot of energy in a short period of time, lifting it directly up. It's a lot like walking up a hill, climbing directly up the hill that's very steep. It takes a lot more force and a lot more energy, a lot more work than walking up a hill that gets gradually steeper and steeper. It takes more time, but it uses a lot less energy and a lot less work. So the last simple machine we'll be talking about is a wheel and axle. Now what this wheel and axle does is it uses torque and rotational force to create a larger output force than its input force. I can apply very little force to the wheel and use it to make a much bigger output force on the axle, carrying a much heavier load. Just like cars, just like carriages, any heavy motor vehicle uses a wheel and axle to create a much bigger output force from its input force, using torque and rotational energy. And that's it for this week. We talked about static electricity and some of the basics of simple machines. Thank you everyone so much for joining me, and I'll see you next week.